We've all heard about AI making things up, right? It's a huge problem. But what if the solution isn't just a better fact checker? What if we could teach AI the power of doubt itself? That's what we're digging into today. Okay, take a look at this. We've all seen stuff just like it. An AI spits out a fact with total, unshakable confidence. I mean, it sounds so sure of itself, right? The grammar is perfect, it seems plausible, but it's completely, utterly wrong. Washington, of course, died a full century earlier in 1799. And that brings us to the central mystery here. How can these incredibly powerful systems, these AIs that have basically read the entire internet, get something so basic so wrong? Why do they hallucinate? All right, so to get to the bottom of this, we have to go way deeper than just calling it a glitch. This isn't just a simple bug in the code. In fact, the source material we're looking at today makes a pretty radical claim. It says hallucinations aren't a bug at all. They're a feature. Yep, you heard that right. It's an inevitable side effect of how these models are designed from the ground up. So we kind of need to redefine what we even mean by hallucination. The old way of thinking was just, oh, the AI messed up and pulled the wrong info. Simple enough. But the new view? It's way more profound. It's not just a retrieval error. It's that the AI sees a gap, a logical hole in reality, and its programming forces it to fill that gap, to smooth it over with a plausible-sounding story, even if that story is total fiction. To really wrap our heads around that, the source material gives us this fantastic metaphor. The problem with current AI is that it sees the world of knowledge as a perfectly smooth, flat plane. But we all know reality isn't like that, is it? It's rugged, it's got mountains, deep canyons, and cliffs you just can't cross. And this really breaks down the difference. On one side, you have today's LLMs with their flat world view. They're obsessed with finding the most probable path between two ideas. They're designed to smooth over any contradictions and connect everything to everything. But this new idea, a topological AI, sees a rugged world. It doesn't just ask what's probable, it asks if a path is even structurally viable. It knows that some ideas have gaps between them, and it knows when to stop at a logical cliff edge. This whole idea is actually formalized in something called the flatness theorem. Now, you don't need to worry about the heavy-duty math, but the concept is actually pretty simple. It says that the very way we train AIs right now, by rewarding them for making smooth, likely predictions, basically forces them to pave over any logical holes. They fill in the gaps with statistical pavement. And here's the kicker. This is the critical consequence. Because its map of reality is perfectly smooth and has no edges, the model can't say, I don't know. There are no blank spots on its map. It will always find a path from point A to point B, even if it has to invent that path out of thin air. Okay, so if the very design of these things is the problem, how on earth do you fix it? Well, this brings us to the solution. We need a completely new way for an AI to test for truth. This is a major shift in thinking. The old paradigm, the one we use now, is all about prediction. The AI is constantly asking, what's the most probable next word? But this new paradigm is about viability. The question changes to, does this entire thought actually hold together? Is it structurally sound? You're not trying to minimize surprise anymore. You're trying to minimize internal collapse. And this new way of thinking is built around a really cool four-step cycle. First, emerge. The AI just brainstorms a bunch of possible ideas. Then, memory. It checks those ideas against facts and rules it already knows. Step 3 is propagate. It tries to build a logical bridge between them. And then, the most important part, step 4 is residue. It actually measures the level of internal contradiction. Is this whole thing coherent, or is it a mess? And that measurement has a fancy name, cohomological residue. But honestly, you can just think of it as a mathematical alarm bell. It's basically a score that tells you exactly how paradoxical or logically broken a thought is. So, if that residue score is 0, that's the green light. It means the thought is coherent, all the pieces fit together, and you're good to go. But if that score is not 0, whoop whoop, the alarm bell goes off. The system has found what's called a topological abstraction, a fatal flaw in the logic. The thought is a paradox. And the key here is that it gets halted, thrown out, not smoothed over. Now, this all sounds pretty high level, but it's not just some abstract theory. The source actually proposes a real architecture to make this happen, a way to engineer, get this, intellectual honesty right into the AI. It's called the Topological Inference Engine, or TI for short. The best way to think about it is like a System 2 brain for the AI. You know, the standard LLM is the fast, intuitive, but sometimes wrong System 1. The TI is the slow, deliberate, analytical System 2 that comes along and checks the work. Its goal isn't just to generate an answer, its goal is to be right. And this is where things get really, really cool. The TIA has this one special component called the kenosis operator. So imagine the TIA runs through all the possible answers to a question and finds that they're all flawed. They all have a high contradiction score. A normal AI would just pick the least wrong one. But the kenosis operator does something completely different. It outputs nothing. Silence. It essentially raises its hand and says, I cannot form a coherent thought about this. This is huge. For the first time, the AI has the ability to just say, I don't know. It replaces a confident lie with honest silence. It turns the bug of hallucination into a feature, intellectual humility. So let's step back for a second, because the implications here are massive. This goes way beyond just fixing wrong dates. We're talking about changing what it even means for a machine to think. The ultimate goal here is a concept called synthetic reflexivity. That's a fancy term for a system that can validate its own internal coherence. It doesn't need an external fact checker, it doesn't need a human to tell it if it's right or wrong, because it can navigate its own complex, rugged map of knowledge and check its own logic. It can think about its own thinking. And this quote from the source material just sums it all up perfectly. We have moved the definition of AI from statistics to topology. It's a total shift. Intelligence isn't just about guessing the next word anymore. It's about building a thought that can actually stand up on its own 2 feet. And that leaves us with one last big idea to chew on. For decades, we've been obsessed with building machines that know everything. But maybe, just maybe, the real leap forward isn't about knowing more, but about understanding the limits of knowledge. So I'll leave you with this question. What changes when our machines finally learn to doubt?